This is an organic chemistry topic test. After you have went through all the videos, introduction, isomers, reactions, so on and so on, you should be able to get everything. Let's go ahead and take a look. So 1.1, which one of the following is the general formula of alkanes? This is just memory work, right? No need to solve anything. We should be able to see that the correct answer is C, because we have memorized that already. And then 1.2, which one of the formula below represents an alkane? Which one of the formula below represents an alkane? This is different from the first question. The first question was saying the general formula, and then in the second question we are looking for the formula that represents an alkane. So A cannot be the correct answer because it is C2H4. The general formula there is CnH2n, which will be an alkene. Same is true with option B, that is an alkene. And then option C, we have C14H30. In terms of N, this would be CnH2n. If we have 14 here, that would give us 28. So because we have 30, it means that is CnH2n plus 2. So the correct answer in 1.2 is C. Right. And then in 1.3, the empirical formula of hexanoic acid. So let's go ahead and look for hexanoic acid. In option A, we have C3, so that cannot be hex. And then B and C. B is not hexanoic acid because the formula there is CnHNO2. I don't know what that is. We don't have that in our context, right? But if you look at option C, that is hexanoic acid. So the answer to 1.3 is not C. It is actually not C. The answer is D. Let me show you how. The question says the empirical formula, right? Empirical formula is the smallest whole number ratio. So C is hexanoic acid, but C is not the empirical formula of hexanoic acid. Right. This is one of those questions where you walk out of the exam thinking, oh, okay, I got it right, only to find out that, damn, I missed the point. So what is written in all caps is very important in this question. Make sure you don't miss that. So the correct answer, 1.3, is actually D and not C. Right. 1.4. Which one of the following terms describes hydrocarbons that contain only single bonds? So isomers, that cannot be the answer. But if you look at B, it says saturated. Hydrocarbons with only single bonds, that is alkane, right? And we know that alkanes are said to be saturated. So the correct answer to 1.4 is B. 1.5. Which one of the following combinations correctly indicates the strongest intermolecular forces found in ethanoic acid and methyl propanoate? Right, so ethanoic acid, we know that we have two sides of hydrogen bonding. So already we know that B cannot be the answer, right? We're looking at A, C, and D. But what is the strongest intermolecular force in methyl propanoate, which is an ester? The strongest intermolecular force there is dipole. So the answer to 1.5 is D. Right, in ethanoic acid we have hydrogen bonding, in methyl propanoate we have dipole. Okay. 1.6, the type of reaction that takes place when a carboxylic acid and an alcohol react in the presence of an acid. Obviously that is option D, which is esterification. 1.7, which one of the following isomers has the lowest boiling point? So let's take a look. In A, we need to have I'm gonna have some sort of a structural formula in order to see what is going on with these. In A, we have 1, 2, 3, 4, 5, 6 carbons. So that is 1, 2, 3, 4, 5, 6. We have something like that in A. And then in B, we have 1, 2, 3. And then this right here is a branch, right? 2 branches to be specific. Why do I say 2? I'm saying 2 because it's CH3. So it can only be a branch. It cannot be part of the chain, because where can you fit the 3 carbons, 3 hydrogens in a carbon and have 2 other carbons attached to it? So that is a branch. So we have 1, 2, right? Followed by a carbon. So that is B. And then C, we have 1, 2, and then we have a branch, as you can clearly see there, CH3. If it was CH2, that's going to be part of the chain, followed by 1, 2, 3. And then D, we have 1, 2, 3, a branch, followed by 1, 2. We are looking for the isomer with the lowest boiling point. So the isomer with the lowest boiling point will be the one that is more branched, which is clearly B, right? So the answer to 1.7 is B. We know that the more spherical compound is, the less surface area it has, lower boiling point, and so on. Okay, 1.8. Which one of the following pairs of compounds are functional isomers? Which one of the following pairs of compounds are functional isomers? So functional isomers should be ketone, aldehyde, or carboxylic acids and esters, right? These are the only functional isomers we have in our context. So A has something to do with alcohol, so already we know that it cannot be the answer. B, I don't even know what this is, butane or something, so it cannot be the answer. And then C, proper 1-ol. What is proper 1-ol, right? Does not even exist. So clearly the answer here in 1.8 should be D, propanoic acid and methyl ethanoate. That is an acid and an ester. Both have 3 carbons. So the answer to 1.8 is D. Let's take a look at 1.9. So in 1.9, which one of the following structural formula of the functional group? Which one of the following is the structural formula of the functional group of ketones? Obviously, the answer is C here because we have memorized it. No need to solve anything. And then the IUPAC name of the compound given. Obviously, the first thing that you're going to look for is the longest carbon chain. So let's take a look. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we can just go straight to make our lives a bit simple. So that is 4, right? So we know that it is butane, but we have these branches here. We're going to start naming from the side closest to the branch. So that will be 2, 2 dimethyl, which is option C. So the answer to 1.10 is C. Right. The long questions, question 2. This structure follows the same exact structure in the exam. In the exam, you'll come across a table like this. Usually, right? Let me say 19 out of 20 times, right? You will come across a table like this, and you're going to answer some questions based on the table. So let's take a look. 2.1.1. The letters A to F in the table below represent 6 organic compounds. Right. The first question, name the functional group of compound B. So compound B is 2-methyl butanoic acid. So that is a carboxylic acid, right? But what is the name of the functional group? Carboxyl group. So carboxyl group. There we go. If it was an alcohol, it would be hydroxyl group. And then 2.1.2, homologous series to which compound C belongs. Compound C, obviously we have this carbon bonded to 2 other carbons, right? And then oxygen. So clearly that is ketones. That is ketones. The homologous series is ketones. And then 2.2.1, we're looking for the IUPAC name of C. We already know that C is a ketone. Now we're just looking for the longest carbon chain. So let's go ahead and, see what is happening. So we have 1, 2, 3, 4, 5. Let's see if we have a longer chain. If we start here, we're going to have 1, 2, 3, 4, 5, 6. So this is clearly our longest chain. right? So which side is closest to the functional group? If we start from the right, we're going to have 1, 2, 3. If we start from the left, we're going to have 1, 2, 3, 4. So clearly we're starting from the right. And then how many carbons? 1, 2, 3, 4, 5, 6. So we have hexane 3 O, right? Now we just need to account for this branch, which is on the 4th carbon. So that is 4- methyl hexane 3O. There we go. Iupac name of compound C. Let's take a look at 2.2. 2.2.2, I mean, the Iupac name of compound D. So compound D looks like it is an alkane, right? So first things first, the longest chain. So this is 1, 2, 3, 4. That cannot be the longest. Let's see another option. 1, 2, 3, 4, 5, 6. Okay, and then if you start here, we're gonna get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3. Seems like 6 is our longest. So let's circle that and see where our branches are located and name the organic compound. So this gives us 6. So we are interested in this, right? So because it gives us 6 and it's an alkene, we already know that we're going to have hexane, right, as the suffix. Now the position of the branches. If we start from the left, we have 1, 2, right? On the 2nd carbon, we're going to have a branch. If we start from the right, 1, 2, 3. So we have to start from the left. That is the side closest to the branch, okay? Which will lead to the least number, okay? So on the 2nd branch, we have 2.2 dimethyl. 1, 2, 3, 4. And then on the 4th branch, we have ethyl. So we're going to have 2.2 dimethyl 4 ethyl hexane. So if you write this, you'd be very close to the answer, but you still be wrong. So we have identified everything the way we're supposed to. Our branches are in the correct position. We've numbered our carbons in the correct way. But when we write our name, the order must be alphabetical. So we're supposed to actually write it as 4-ethyl 2.2 dimethyl hexane. Right, we just changed and we started with ethyl before methyl because ethyl comes before methyl alphabetically. We don't care about the di, right? We don't care about the di. Right, so don't think that I'm being too strict. You will get penalized if you don't write the Iupac name in alphabetical order. Right, this is not a matter of preference, it's a must. We're supposed to write it like this. But anyway, stories. Let's carry on. 2.3, write down the name or formula of each product formed during the complete combustion of compound D. So compound D is an alkane, and combustion, burning in excess oxygen, right? And the products is always CO2 plus H2O. So the correct answer to 2.3, you shall write CO2 and H2O. This is the correct answer. Obviously, you can write carbon dioxide and water because we were looking for the name of formula, but that's what we are essentially looking for. 2.4.1, write down the structural formula of compound B. B is 2-methyl butanoic acid. So 1, 2, 3, 4, because it is but. It is butanoic acid, so it is an acid. That is where I'm going to position the functional group. And then 2-methyl, so we have a branch on the 2nd carbon. So the 2nd carbon has to be this one, right? Because we are going to start numbering from the side closest to the functional group, which is that one there, right? So this is 2-methyl butanoic acid. 1, 2, 3, 4. 1, 2, 3, 4. Right. I always make sure that I have the correct number of bonds. So there we go. 2-methyl butanoic acid. Right. 2.4.1. Let's go ahead and do 2.4.2. Structural formula of a chain isomer of compound A. Compound A is an alkene, right? So structural chain isomer is same molecular formula but different chains. So we can just write this. We can just write the but2 in, because we're gonna have the same molecular formula but different position of the functional, but different chains. I'm sorry, that is different position of functional group is functional isomer. Here we're talking about different chains, right? So 1, 2, 3, 4. Let's put the double bond there and then fill out the hydrogens. So this is what we have, right? This is the chain isomer. Same molecular formula, different chains, right? So that is 2.4.2. I'm just trying to calculate the number of carbons, the number of bonds, and see if they're correct. Seems correct. 2.4.2. And then 2.5, let's go. A laboratory assistant uses bromine water to distinguish between compounds D and E. Okay, D is an alkane and E is an alkene. Right, let's hear the stories. She adds bromine water to a sample of each in 2 different test tubes. She observes that one compound decolorizes the bromine water immediately, while the other one only reacts after placing the test tube in direct sunlight. Write down the letter D or E of the compound that will immediately decolorizes the bromine water. So the compound that will immediately decolorizes the bromine water should be alkene, right? Because we're going to have an addition reaction take place there immediately without sunlight, as you would need if your compound is an alkene. And then 2.5.2, name the type of reaction that takes place in the test tube containing compound D. Compound D is the alkane, right? Ane and in. My handwriting is so bad. So the type of reaction that takes place if your organic compound is an alkane should be substitution, right? Substitution. Yeah, because we have an alkane and then we are adding Br2 essentially. So we cannot be eliminating anything there. So obviously it is going to be substitution, because in an alkane you cannot have addition either way. 2.5.3, structural formula of the organic compound formed in the test tube containing compound E. So compound E, when it reacts with bromine water, addition reaction is going to take place, because we have an alkene. I've said it before that if a reaction starts with an alkene, it is an addition reaction. No questions asked. So this is the alkene, right? 1, 2, 3, 4. Because it is said that we have built 2 in. Okay, so this is the alkene that we start with. And then we add, it is in bromine water. So it is essentially plus Br2. So obviously what is going to happen, this double bond is going to break. And what are we going to have? Right, we're going to have Br and Br. Right, there we go. That is the structural. That is the structural formula of the organic compound formed in the test tube containing compound E, right, which is but2 in. That is question 2. These are the types of question that you expect. Question 3. Let's take a look. There's a mistake in this question, right? Compound A was supposed to be propanol and not propanol. So this is supposed to be propanol and not propanol, right? If it is propanol, 3.1.1 and 3.1.2 won't make sense. So that had to be propanol. Okay, so let's go through the questions after we fix the error. A is not propanol, it is propanol. And then the first question will be, to which homologous series do the above compounds belong? If A is propanol, you can see the issue that arises, right? Do you say alcohols or do you say ketones? But if A is propanol, then the answer is simply ketones. That is the homologous series to which they belong. All right. And then 30.1.2, the melting points of compound A, B, and C are compared. The question says, write down the control variable for this comparison. The control variable is what's the same throughout the compounds that you're comparing, right? If A is propanol, then the control variable would be functional group. Another possible answer would be homologous series. Homologous series. Right, that is another option you would have there. Okay, and then 3.1.3, the melting points the melting points of compounds C and D are compared. Fully explain the difference in melting points of these two compounds, C and D. So C is pentane 3-one, so it is 1, 2, 3, 4, 5 pentane 2, not pentane 3 but pentane 2. Okay, so this is what we have, that is compound C. Okay, and then compound D, we have 3-methyl butanol, so that is 1, 2, 3, 4, because it is but, so double bond oxygen, and then we have a carbon there. So you can see that these two organic compounds, they differ in terms of branching, right? D is more spherical, D is more branched compared to C. So how would you then answer this question? Look at the mark allocation. It is 4 marks, right? So you need to touch on quite a few things in order to get these entire 4 marks. So the first line, you have to state that compound D is more branched compared to compound C. We can clearly see that, right? And then the second line, here you've talked about branching. You write it in full, right? That compound D is more branched compared to compound C, right? And then now you will go on to say the less branched a compound is, the stronger the intermolecular forces. So compound C, so the intermolecular forces in compound C are stronger than the intermolecular forces in compound D. So right, the IMF, the intermolecular forces in C are greater than the intermolecular forces in D. Please don't write it like this. Don't just say 1 branching 2 IMF greater. No, don't do that. Write it in full sentences, right? I'm just doing this for the sake of time. And then the third point, more energy would be required to overcome the intermolecular forces in compound C, right? More energy is going to be required to overcome the intermolecular forces in compound C, right? And then number 4, the finishing line, leading to a higher melting point, boiling point, viscosity, but a lower vapor pressure in compound C. So that is how you explain the difference in the melting points between these two compounds. 3.1.3. Let's take a look at 3.2. So 3.2, the table below shows the results obtained from an experiment to determine the vapor pressure of different straight chain primary alcohols at 300 kelvins, I would assume, right? And then 3.2.1, we're supposed to define the term vapor pressure. I'll let you do that. And then 3.2.2, write a suitable conclusion for this investigation. So let's take a look at our data. We have C1, C2, C3, C4, C5, C6. And then the vapor pressure 16.8, 7.88, it keeps going down. So clearly, as the chain length increases, the vapor pressure decreases. That is a suitable conclusion. As the chain length increases, the vapor pressure decreases. Okay. And then 3.2.3, Write down the IUPAC name of the alcohol with the highest boiling point. Obviously, we know that the higher the boiling point, the lower the vapor pressure. So this is the alcohol with the highest boiling point, as it has the lowest vapor pressure. So that is C6. So because it is 6,6, we're gonna have where am I saying bute? Wow. We're gonna have hexane 1-ol. Hexane 1-ol. 3.2.3. Now let's do 3.2.4. The experiment is now repeated at 320 kelvins. Will the vapor pressure of each compound increase, decrease, or remain the same? Yes, the vapor pressure of each compound will increase. The vapor pressure of ethanol would still be greater than that of propanol, and that of propanol will still be greater than that of butanol.